Welcome in this new video. 12th science students, subject chemistry, topic chemical kinetics. From this video we going to study first order reaction and its integrated rate law. Video presented by Mr.R.G.Taware, Gopal Krishna Gokhale College, Kolhapur. Let's study first order reaction. So in last video we discussed the differential rate law that gives an information how a rate of reaction depends on the concentration of the reactant. Consider a first order reaction. A gives product. Consider the concentration of reactant A is 0.2 molar. On that specific concentration, the rate of reaction is 0.30 molar per second. Now, we change the concentration of reactant A. Now it becomes double. The rate of reaction also double. From 0.2 molar, we double the concentration, that is 0.4 molar. The rate of reaction also double, that is the reaction is first order reaction. Whenever we increases the concentration of reactant by 2 times, the rate of reaction also increases by 2 times. That is, there is a linear proportion between the concentration of reactant and the rate of reaction. Whenever we increases the concentration of reactant by 3 times, the rate of reaction also increases by 3 times. ज्या प्रमाणामध्ये आपण रिएक्टंटचं कॉन्सन्ट्रेशन वाढवू त्याच प्रमाणात रिएक्शनची रेट सुद्धा वाढणार आहे. दॅट इज त्या रिएक्शन ह्या फर्स्ट ऑर्डर असणार आहे. फर्स्ट ऑर्डर रिएक्शन, लेट्स सी डेफिनेशन. द रिएक्शन होज द रेट डिपेंड ऑन सिंगल रिएक्टंट कॉन्सन्ट्रेशन raised to first power is called first order reaction. Second definition, the reaction in which rate of reaction is linearly proportional to only one reactant concentration. There is a direct linear relationship between single reactant concentration and the rate of reaction. Whenever we increases the concentration of reactant by 2 times, the rate of reaction also double. That is a linear relationship between reactant concentration and the rate. Let's see integrated rate law. मागील व्हिडिओ मध्ये आपण बघितलेला होता डिफरन्शियल रेट लॉ. इट गिव्स a rate of reaction, how it depend on the reactant concentration. Now let's see integrated rate law. The equation which are obtained by integrating the differential rate laws gives a direct relationship between the concentration of reactant and time are called integrated rate law. This means that it is important to know the rate of consumption of the reactant. How will the reactant concentration will remain after specific time t. That is the relationship between the reactant concentration and time that is given by integrated rate law. Now let's see the derivation of integrated rate law of first order reaction. Consider a first order reaction. A gives product. The differential rate law of first order reaction is rate is equal to minus d concentration of A divided by dt is equal to K into concentration of reactant A raised to 1, as single reactant concentration raised to first power for first order reaction. Now for integrate, let's see first concentration of A, that is the concentration of reactant A at time t, minus d concentration of A divided by dt is the rate of reaction measured at time t at which A is converted to product. That is the rate of reaction. So according to differential rate law, rate is equal to minus D concentration of A divided by dt is equal to K into concentration of reactant A raised to 1. Now student, this specific differential rate law we have to integrate, and for integration it requires limits. First we rearrange and integrating the equation within the limits. Limits proper बघा, concentration of A at time 0, that is initial concentration, it's denoted as concentration of A 0. After time t, that is reaction proceed झाल्यानंतर एका specific t time ला reactorचं concentration decrease झालेले असणार आहे, and it reaches to concentration of AT, that is at that time t is equal to t, the concentration of AT, and time t is equal to 0, the concentration of reactant A is A0. Now student, we have to integrate this equation within the limits. On integrating within the limits, A concentration of A0, upper limit concentration of AT, D concentration of A divided by dt is equal to integration sign च्या बाहेर constant, that is K, integrating within the limits t is equal to 0 to t is equal to t dt. Time ची term, rate ची term. Now concentration of A 0 to AT D concentration of A divided by dt is equal to K minus integrating within the limits t is equal to 0 to t is equal to t dt, where A0 is the initial concentration and AT is the concentration of reactant A remains unreacted at time t. On performing the integration, हे इंटिग्रेशन परफॉर्म केल्यानंतर सॉल्व केल्यानंतर आपल्याला मिळणार आहे ln concentration of A, lower limit concentration of A0, upper limit concentration of AT is equal to minus K T 0 to T. I repeat, on performing the integration, ln concentration of A within the lower limit concentration of A0 to AT is equal to minus K in bracket T0 to T. On solving, on substituting the upper and lower limits, we get ln concentration of AT minus ln concentration of A0 is equal to minus KT. Ln, that is log terms, subtraction, that is division, ln concentration of AT divided by A0 is equal to minus KT. ln च्या टर्म, that is log च्या टर्म्स ही सबस्ट्रॅक्शन असल्यामुळे इथे डिव्हिजन केलेली आहे. ln concentration of AT divided by concentration of A0 is equal to minus KT. ln concentration of AT divided by A0 is equal to minus KT. So KT इनवर्स केल्यानंतर निगेटिव्ह साइन निघून जाणार. KT is equal to ln इनवर्स केल्यामुळं concentration of A0 divided by concentration of AT. हे ln ची टर्म आहे. दॅट इज टी आता या बाजूला घेऊया. K is equal to 1 upon T ln concentration of A0 divided by concentration of AT. ही ln ची टर्म लॉग्स मध्ये कन्वर्ट करण्यासाठी कन्वर्टिंग ln into log 10, the integrated rate law becomes, या इक्वेशनला ln चं लॉग करत असताना 2.303 न मल्टिप्लाय करतो. सो इक्वेशन बिकम्स K is equal to 2.303 divided by T log to the base 10 concentration of A at time t0 divided by concentration of A at time t. This is the first form of integrated rate law of first order reaction. I repeat, K, that is the rate constant for first order reaction, is equal to 2.303 divided by T log to the base 10 initial concentration of reactant divided by concentration remain at time T, that is A naught divided by A T. Let's take this equation again, that is ln concentration of A T divided by A 0 is equal to minus KT. Taking antilog of both side as, दोन्ही साइड से अँटीलॉग केल्यानंतर लॅन टर्म निघून जाऊन ही टर्म एक्सपोनेन्शियल होणार. टेकिंग अँटीलॉग ऑफ बोथ साइड एज कॉन्सन्ट्रेशन ऑफ ए टी डिवाइडेड बाय कॉन्सन्ट्रेशन ऑफ ए 0 इज इक्वल टू एक्सपोनेन्शियल मायनस के टी. ए नॉट ह्या साइडला घेतलं, कॉन्सन्ट्रेशन ऑफ ए टी इज इक्वल टू कॉन्सन्ट्रेशन ऑफ ए 0 इंटू एक्सपोनेन्शियल मायनस के टी. This is second form of integrated rate law of first order reaction. 2K is equal to 2.303 divided by T log to the base 10 initial concentration of reactant divided by concentration at time T, that is the first form. And second form, concentration of AT is equal to initial concentration of reactant into exponential minus KT, that is second form of first order reaction. Whenever we solve the concentration of the reactant and relationship with time, we have to use generally K is equal to 2.303 divided by T log to the base 10 initial concentration of reactant divided by concentration of reactant remain unreacted at time T. That is the first form of first order reaction. Thank you.